Okay, question 4 looks quite tricky. It's not as bad as it appears. This one in particular looks scary. This one we should be able to know what to do to start with. And don't worry that there's 2 equations. They're going to both be useful later. So we've got that sec squared a minus tan a equals 13. And we can relate sec to tan, or we can relate sec squared to tan squared, using one of our special formulae. And it's the one that comes from the sine squared theta plus cos squared theta equals 1. If we take sine squared theta plus cos squared theta equals 1, or sine squared, let's write sine squared a, and divide each of these terms by cos squared a, then we get tan squared a plus 1 equals sec squared a. So we can swap this sec squared a for tan squared a plus 1. So we've got tan squared a plus 1 here, and then we're going to take away tan a, and we're told that that equals 13. If we rearrange this, tan squared a take tan a, take away 12 equals 0. And this is now a question that looks like a quadratic, so we can solve it as if it was a quadratic. I'm going to write t for tan. And this will factorise quite easily to negative 4 and positive 3. So tan a is either 4 or negative 3. Now, we don't need to work the a values out, because we are going to want later on tan a minus b, so we just need to know tan a and tan b. So we've got 2 possible values for tan a. What about tan b? Well, what can we do with this? As I said, it looks quite difficult, it looks quite scary. There's a few different things we could do with it, but what I'm going to do is I'm going to take this sec squared b and this cosec squared b and rewrite that as 1 over cos squared b and 1 over sine squared b. So in other words, we're going to have sine b over cos squared b, because it's being times by 1 over cos squared b, 1 over cos squared b, and that's going to equal 27 cos b over sine squared b. If we multiply by cos squared b and sine squared b now to get rid of these fractions, we're going to end up with over here sine cubed b and 27 cos cubed b. And if we divide by cos cubed b, we're going to get tan cubed b. And if we cube root, we're going to get tan b. Cube root of 27 is 3. So tan b is 3, and tan a is either 4 or negative 3. And that's everything we need to be able to work out tan of a minus b using our addition formula. And this is in your booklets, this is in your formula booklet, but tan a minus b is equal to tan a minus tan b divided by 1 plus tan a tan b. So we're going to have 2 possible answers because we've got 2 possible values for tan a. So if we look at when tan a is equal to 4, we're going to have 4. We know that tan b is definitely 3, it's always 3. So 3 here, 4 here, and then we're going to have 1 plus 4 times 3. So that's going to be 1 over 1 plus 12. So 1/13 is one possible value. But when tan a is our other possible value, negative 3, we're going to have negative 3 take away 3 over 1 plus negative 3 times positive 3. And that's going to come out at minus 6 over 1 minus 9, so that's negative 8. So that cancels down to 3/4. So those are our two final answers, 1/13 or 3/4.